Hello, my name is James, and I'm the CEO and co founder of Julius Technologies. And today I'm going to walk you through a live demonstration of the Julius Core and a few use cases of what our platform can do. It's widely understood that the growing complexity and opaqueness in modern IT systems are the main bottlenecks for data driven transformation. This black box plumbing drives up costs, stifles innovation, and adds operational risks for companies both large and small. At Julius, we offer a low code, visual graph computing solution that brings full visibility and flexibility to data and analytics systems, helping companies to build and adapt data and ML pipelines faster and cheaper than ever before. Graph computing is an emerging technology that will play a foundational role in analyzing the interconnected data of the future. But most firms today can't benefit from graphs because they don't have the expertise and resources to build their own solutions. Julius brings the power of graph computing to the masses by making it easy to use and deploy at scale. Our low code tools have helped clients create solutions for ML fraud detection, complex data wrangling, and data ops at a fraction of the cost and time it normally takes. Companies can now see how their systems work at every step of the way, which makes it so much simpler to understand, develop, and manage. The first example we're going to show is an end to end machine learning model for credit approval. This is actually an accurate representation of a major bank's credit approval system. We built this application in a matter of days to replicate a system that took tens of thousands of personnel hours to create. On the screen, we're showing the 32 rules that fully specifies this use case, from data sourcing to data cleansing, feature engineering, model training, and performance monitoring. From these rules, Julius then creates an end-to-end system in seconds that shows exactly how every piece of data and analytical logic is being used. Now, I realize this looks complex because the process is complex. But for the first time, business and IT teams can actually see their creation in action, which makes it so much easier to understand and maintain. The first thing you'll notice here is that there are several colors on the graph. Here, the different colors represent different physical computers. Julius automatically distributes the workload across multiple machines, which can be on premise or in the cloud. We offer an intuitive web UI where a user can click on any node on the graph to visualize the corresponding data as of that point of the process. So, for example, this node shows the raw data, which could be loaded from any data source, such as a data lake, Hadoop, unstructured files, etc. The next few nodes show how the data is being processed and transformed with each step. This node shows the results of feature engineering with added columns. And if we skip ahead to this node, you can see a trained decision tree model. We allow complex data and analytical logic to be organized in a clean hierarchy. In this case, a user can drill down to the inner logic to see how exactly a credit approval or rejection decision is made. With drill down, these low level details don't have to clutter the top level of the system, which makes it much easier for a user to visualize and navigate the system. Further downstream, we also report the performance of the machine learning model using ROC curves, Gini metrics, or any other metrics a developer wants. We also integrated the model documentation process into the same system, so a developer can describe the corresponding data and analytics at any node. Then, with a single click, we can generate the entire end-to-end documentation with actual live data populated. This is a huge time saver because we automate most of the manual work associated with model documentation and governance, which is a huge pain point for regulated entities. The next example we're showing is the machine learning hyperparameter tuning. Here we reuse the same set of rules in the previous example, but now test four different machine learning algos and different hyperparameters so that the client can choose the best model implementation for production. In this case, we are using open source algos, but we give clients the flexibility to use their own in-house or third-party libraries as well. This example only took 14 rules to build, as it leverages the components and rules we built before. One of the important features we want to highlight here are the metadata capabilities. With Julius, we allow users to create their own metadata tags and define how they should be applied throughout the system. For example, here we are showing a simple user-defined metadata of CPU usage for different ML algos, from which we can easily determine which ML algo has the best trade-off between accuracy and speed. The metadata is context-aware, so by clicking on different nodes, we're seeing only the CPU usage up to that particular node. The metadata capabilities are tremendously useful and have many different applications. For example, we can use it to protect data privacy by tagging all the derived data that come from private sources and apply access control based on that. Or we can use it to track data quality, such as whether a result depends on any data sources that haven't been signed off. Metadata can be a lifesaver when it comes to audit. For example, if an audit team asks a data scientist to prove that no private data is ever used for certain output, it can be a very time-consuming task to answer in practice. They pretty much have to perform a full audit of the entire code base. Using Julius, the question can be answered in a matter of minutes using our metadata capabilities. I want to emphasize that our platform can scale to handle enterprise-level data and analytic needs. For example, we have created use cases that can process billions of credit card transactions or can price millions of trades in a bank's portfolio. For the third example, we're showing the pricing of 100,000 derivative trades with full sensitivities. This example is a lot more complex with 1 million nodes in the graph, which is far too big to fully display on a single screen. As with our previous example, our system automatically handles the distribution and data feeds behind the scenes and self-scales as needed. To create this complex and large system, a developer only needs to write 69 rules in our design language, which in practice would replace millions of lines of code. Because the entire system is auto-generated, we can ask the Julius platform to also automatically generate the end-to-end adjoint algorithmic differentiation, or AAD, without much effort from the developer. This link shows the full AAD deltas of a cross-currency swap. Using AAD, the Julius platform can compute sensitivities thousands of times faster than the traditional bump and reval approach. So I hope several key benefits of the Julius platform have become clear at this point. First, it is low code. We only need a few rules to build entire systems with a sophisticated data and analytics pipeline. Second, the system is fully transparent with end-to-end data and analytics lineage, which is incredibly powerful as an ETL tool. Julius can process data from multiple sources and formats for many use cases, including data science, regulatory reporting, and more. Thirdly, the system is built virtually and on demand. Therefore, it is fully elastic and can seamlessly adapt to clients' changing needs. For example, if the client wants to add a new data source or change the ML model, They just need to add or modify a few rules, and the Julius platform can regenerate the entire system with a new functionality in a matter of minutes. The platform also offers unlimited performance and scalability and a full suite of useful tools and features, such as integrated model documentation, metadata, and end-to-end AAD. Because of the time limit, we're only able to scratch the surface of what Julius can do. Please reach out to us if you want to see a full demo of our system. We truly believe this is the future of data analytics systems. Thank you.